Good evening, students. Sorry, had a technical issue. We were discussing ray optics, right?
Yes.
So, till what point did we discuss?
The focal length part.
So, we saw that the
R equal to F by 2 part.
yes, R is equal to F by 2. That is a part till which we discussed. Right. So, previous class, I told you about the different parts. Did we speak about the ray diagrams also in the previous class? Did we speak about how to draw the ray diagrams? Yes, sir. No? So now we'll be discussing about ray diagrams also. One thing that we started with this in this chapter is, what did I tell you guys? I told you that we will be dealing with, I told something important. We'll be dealing with objects. We'll be dealing with mirrors that are small aperture, and the rays that you consider will be paraxial in nature. Will you tell this or not? Right? So to construct the image of an extended object, what do you mean by extended object? An object that has a finite size associated with it. So if you have to locate the image of an extended object, then what are we supposed to do? Yeah. So we need to draw a ray diagram. So what does that ray diagram do? How does that ray diagram help us find something? What does it do?
The nature of the image found.
So it will tell us the location where the image is formed, correct? So how many steps are there for us to, how many rules are there for us to draw the ray diagrams? There are 4 rules that we can consider. Basically 4 incident rays dependent on which how the refracted rays are going to be, correct? Now tell me one thing. So whether you talk about a con or a convex mirror, if you take a ray through the center of curvature, then how is it going to travel? It will get reflected back along the same path. Why? All these rules you would have learned in your 10th standard. Why is no one speaking? Only one guy is speaking. Others don't even know. Yeah, Niklesh, you tell them. Better we both will speak. So ray through the center of curvature is reflected back along the same path. What is the meaning of it?
So it will go back and come in the same path, means the angle of incidence will be 0.
Correct. That is what I was expecting. Means the ray will hit the surface normally. Means the angle of incidence will be equal to 0 degrees. Correct. So ray through C strikes the mirror normally. So whenever you say a ray is hitting the surface normally, means the angle of incidence is 0 degrees. That is what you need to have in your mind. And the angle of reflection will also be 0 degrees. Correct? So if you take a ray through the if you take a ray through the center of curvature, then the ray itself will act like the normal. What will happen with respect to a convex mirror? This is a wrong diagram. With respect to a convex mirror, what will happen? If the ray is hitting the surface like this, it will retrace its path provided it is passing through the center of curvature. We know this fact, right? Then what about ray 2? So if you take a ray which is parallel to the principal axis, after reflection, what will happen to it? It will pass through the principal focus. So it will appear as if so it will pass through the principal focus for a concave mirror, whereas for a convex mirror, what will happen? It will appear as if it is diverging from that point. Correct?
Yes, sir.
So when I take a ray parallel to the principal axis, after reflection, it will pass through the focus for a concave mirror, whereas for a convex mirror, what will happen? It will appear as if it is diverging from this point. Okay, ray 3. So when you talk about a ray passing through the principal focus, what will happen is just the reversibility of light. When the ray is passing through the principal focus, or ray appearing to converge at focus F is reflected back parallel to the principal axis. It's exactly the reverse of what we did in the previous case. Okay. Then what about the fourth ray that we are going to consider? If a ray is striking the pole, then it will get reflected back symmetric with respect to the principal axis. Correct? Because in this case, what will happen? The principal axis itself will act like the normal. So when this is the normal, the angle of incidence and the angle of reflection will have the same magnitude according to the laws of reflection. That's it. So these are the four rules with which we can form or locate the position of an image. Right? Now, based on all these formulae, we will be deriving the mirror formula, or we call it as mirror equation. So what are the formula is? You already know. There is an equation that gives you the relation between the object distance, image distance, and the focal length. 1 by v plus 1 by u is equal to 1 by f. Okay, just a minute. Okay. Now I will take a concave mirror into consideration. If I take a concave mirror like this, okay, you have the principal focus here, you have the center of curvature. So if I place an extended object AB here, then where do we locate the position of the image for this object? How do we locate it? Can you guys tell me how to draw the ray diagrams? When you take a ray parallel to the principal axis, after reflection, it will pass through the
Focus.
Right? Similarly, if you take a ray through the center of curvature, it will retrace its path. If you take a ray which is hitting the pole, it will reflect back symmetric. Correct? So we have taken these all these rays will meet at a point to give you the image of the object, which I will call it as A dash B dash. Sharia? No. See, there are two important rules that you need to have in your mind with respect to the derivation of this formula. What is it? Let's think about it. One is, the name of the chapter is ray optics, correct? So when I call it as ray optics, it is also called as geometric optics. You guys remember I told you that there is another name for this chapter, geometric optics. So it is called as geometric optics because we can take the help of geometry to understand the relations between different distances. Okay. Now listen to this very carefully. Whenever you're trying to, there is a case where you need to derive the relation between the distances, okay, You can either go with trigonometry or you can use a geometry that is the similarities of triangles. So when I say you need to apply the formula of similarities of triangles, you need to look for the set of triangles which are similar. So what is one set that I'm able to see is the triangle BAC, where A is 90 degrees. If I say angle C is theta, then I have a triangle B dash A dash C, where again this angle is theta. Okay. So what is the distance from P to point A? It is the object distance. From point P to A dash, it is the image distance. From the point P to C, it is the radius of curvature, and from the point P to F, it is the focal length. Correct? Can I say something like this? Right. So, which are the two triangles that are similar? Triangle BAC is similar to triangle B dash A dash C. Right. So, BA divided by B dash A dash is equal to, can I write it as AC divided by A dash C? I'm taking vertical divided by the horizontal. See, that is one way, or else what I can do is I can take this as theta, I can take this as theta. Tan theta is equal to AB by AC, and tan theta from the other triangle is B dash A dash divided by AC. You'll still get the same thing. Okay, what is BA? BA is the height of the object. B dash A dash is the height of the image. See, I wanted to tell you one important point here. You guys know what is sign convention, right? You guys know what is sign convention? Yes or no? So what does sign convention mainly speak about? It tells you the nature of the sign. That is, which side distance is supposed to be taken as positive and which side distance is supposed to be taken as negative. All these things are spoken about the sign convention. So if you take the point P as the origin, all the distances measured on the left hand side are, what are they? All the distances, they are negative, and all the distances measured on the right hand side are positive. Upward distances are positive, downward distances negative. We know this fact, right? So when this is going to be the scenario, then BA, I will call it as height of the object. What is B dash A dash? It will be height of the image, but with a negative sign. Correct? This will be equal to, AC is how much, guys? AC is U minus R. But since all the distances are on the left hand side, you need to take a minus sign. Divided by A dash C is how much? It is R minus B with a negative sign. Correct? So minus will get cancelled. H0 divided by Hi will be equal to U minus R divided by R minus. So, oh, sorry, there is a minus sign. Let me call this as equation. Okay. This is the first set of similar triangles that we are able to find. So please write down this part. Now, what is the second set of similar triangles that you're able to see? Search for two more right angle triangles which are similar. Okay, tell me what are the other sets of right angle triangles you're able to see?
BAP, sir.
Correct. Then BAP and B dash A dash. Correct. So if you take the triangle BAP, it's something like this. B is here, A is here, P is here, where this is 90 degrees. And B dash A dash T is also there. Sorry, correct. So B dash A dash P is also there, where this angle is going to be. So this angle, if I take it as theta, this angle is also theta. Correct? So BA divided by B dash A dash is equal to AP divided by A dash B. So what is BA? Height of the object. This is the height of the image. Height of the object divided by minus HI is equal to, what is AP, guys? What is AP? The distance between the foot of the object and the pole is called as the object distance. Minus U divided by A dash P is minus V. So they both will get cancelled. H naught divided by HI with the negative sign will be U by V. Let me take this as 2. So from 1 and 2, what is that we can conclude? U minus R divided by R minus V is equal to U divided by V. Okay, which implies UV minus VR is equal to UR minus UV. Rearrange this equation. 2 times UV is equal to UR plus VR. So divide it with UVR on both the sides. Divide with UVR on both sides. 2 times UV divided by UVR is equal to UR divided by UVR plus VR divided by UVR. VR, VR, UR, UR, UV, UV will get cancelled. 2 times R is equal to 1 by V plus 1 by U, which implies 1 by V plus 1 by U is equal to 2 by R. I will write it as 1 by. So this is what is a mirror for. Okay. So the important points to be noted here is sign convention should be applied while deriving the formula. Secondly, sign convention should be applied while solving problems. Clear? Next is the formula for magnification. So what does magnification mean? Here magnification also means linear magnification. What is this? You already know what is linear magnification, right? You know the definition of it. What is it?
V by U, right?
It is a ratio of something, right?
Ratio of ratio of the object to the image formed.
Think about it.
So object length to the
See, I'll give you a hint. Magnification is similar to efficiency. Now think about it and answer. It is a ratio. See, efficiency speaks about output divided by input. Then, if I say magnification is something similar, it is the efficiency of the mirror. Right? So, what will it be?
of the object to the size of the image formed.
It is the ratio of the size of the image because that is output
Okay.
to the size of object. So, when I say size here, I refer to the height. That is why I called it as linear magnification. So, it is represented by the symbol hi divided by h0. So, ratio of height of the image to the height of the object is what we call it as magnification. Correct? Now, seriously, I'm not able to concentrate because of the silence. You know, my brain is not working, and I'm actually forcefully trying to teach. So this there no height of the object to the height of the image. The second equation is there no. What did I write? H0 by HIR. I wrote something like this, right? So this implies HI divided by H0 is equal to minus V by U. Correct? So I just take the I just took the reciprocal on both the sides. Minus HI divided by H0 will be V by U. So that minus sign pushed to the other side will become minus V by U. What is this HI divided by H0 called as?
Magnification.
Magnification.
So magnification will be minus V by U. So the magnification of a mirror is given by the formula minus V divided by U. Okay, maybe in your lower grade you would have learned it as minus V by U, but now you would have understood what is the reason. Right. So copy it. Right? Are you done? Now we will try to solve one or two problems. So there is an object which is placed at 10 centimeter and 5 centimeter in front of a concave mirror of radius of curvature 15 centimeter. So U is how much?
U is 10 cent.
But whether you talk about a concave mirror or a convex mirror, it is always negative. So U is equal to minus 10 centimeter in front of a concave mirror of radius of curvature 15 centimeter. So radius of curvature with respect to a concave mirror, is it positive or negative? This concave mirror. Object should always be kept on the left hand side. Radius of curvature will be somewhere
Negative.
Yes. Find the position, nature, and magnification of image in each case. Find the position. So 1 by V plus 1 by U is equal to 1 by F. This 1 by F can also be written as 2 divided by R. So 1 by, whichever is the unknown, don't apply sign convention to it. Plus 1 divided by U is how much? It's minus
1
10.
by minus 10.
2 divided by minus 1. So 1 by V is equal to 1 by 10 minus 2 by 15. What will be your answer? 15 minus 20 divided by 150. So it will be minus 5 divided by 150. So V will be minus 30 centimeters. Okay. So V is equal to minus 30 centimeter. Now, how to validate whether this is right or wrong? Okay. So how to do this is, see. If I take a concave mirror, the radius of curvature of this concave mirror is given as 15. So center of curvature lies at a distance of 15 centimeter. Where is the focal point? It is at a distance of
7.5.
7.5 centimeter. Where is the object placed? It is placed between the center of curvature and the focus. Right. With respect to a concave mirror, there are 6 ray diagrams. And from those 6 ray diagrams, what is that you understand? When the object is placed between the center of curvature and focus, where is the image formed?
It will be beyond the center of curvature, right?
Correct. So it will be beyond center of curvature. So center of curvature is at a distance of 15 centimeter. So your answer says minus 30. So the object and the image are on the same side. So it is a real image. And B is equal to minus 30 centimeter is beyond C. Correct? Correct?
Yes.
And we know the fact that real images are always inverted. Right? So they ask the position, shape, nature, and magnification. Position is minus 30. Nature is real and inverted. And magnification is what we need to find. Magnification is minus B by U. Minus is in the formula. B is minus 30. U is how much? Minus 10. Cancel it.
Minus
Get minus 3. So minus 3 and it has not have units. So minus 3 indicates again it is a real and inverted image. So magnification with respect to a mirror negative means it's a real image. And the magnitude of this magnification is how much?
Negative. So it means
Hey, magnitude, yeah?
so 3.
Magnitude is 3. So if the magnitude of magnification is greater than 1, it says it's an enlarged image. Only if it is enlarged, the size of the image will be greater than the size of the object. You're able to understand? So it forms a real and inverted image, and the image is magnified. Magnified or enlarged, both mean the same. Okay, am I clear with this?
Yes, sir.
Can you guys try the next one and tell me the answer? So the same problem, if the object distance is 5 centimeter, what would be the position, nature, and size of the image?
So 15 centimeter, right?
How much?
15,
8.
15, sir. 15
15.
Plus 15 or minus 15?
plus size.
You got plus 15. Huh? So U is minus 5, correct?
So I think, so I did a mistake. So I'll read.
1 by V plus 1 by U is 1 by F, or it is 2 by R. 1 by V minus 1 by 5 is 2 by minus 15. 1 by V is minus 2 by 15 plus 1 by 5. Am I right?
Yes, sir.
So minus 10 plus 15 divided by 75. You will get 5 divided by 75. It is 1 by 15. So V will be plus 15 centimeters.
Plus 15.
So what do you understand from this? Object distance is negative. Image distance is positive. So it forms a
Virtual image.
virtual image. Let's recollect the ray diagrams. When you take a concave mirror, the focal length of this concave mirror is 7.5 and the object is placed at 5 centimeters. Correct? Huh?
Image is found on the other side of the mirror.
Because it is placed between the focus and the hole. So this is the only scenario where you will get a virtual image. So this is the only place where a concave mirror will give you a virtual image. Right? That is one thing. And it gives you a magnified virtual image. So we'll calculate the magnification minus V by U. Minus is in the formula. V is 15. U is how much?
5 minus 5.
Cancel it. It is 3. So magnification positive implies it's a virtual image. Virtual images are always erect in nature. Virtual images are always upward. They are straight in the upward direction. Right? So it forms a magnified, virtual, and erect image. Okay. So this is all about reflection. I'll just give you an introduction of what is refraction. Okay. So what is that you know about refraction? What is the difference between the phenomenon of reflection and refraction?
So in refraction, the direction will be changed, but it won't be completely sent back like reflection.
Okay. So reflection is bouncing back. Refraction means it will travel from one medium to another. If there is a difference in the properties of the medium in terms of optical density, then what will happen? A ray which is traveling from one end to another, one medium to another, will start getting bent. Correct? So the phenomenon where there is bending of light taking place when the ray is traveling from one medium to another is what we call it as refraction. So please write it down. When a beam of light encounters another transparent medium, a part of the light generally gets reflected back to the first medium, while the rest enters the other. Okay. Now, The phenomenon of refraction is something like this. Bending of light when it travels from where to where?
One medium to another.
When it travels from one medium to another. And what should be the difference in the media? They should have different optical density. Okay. So I use the word optical density. So optical density is decided by two parameters, where one of the parameters is called as rarer medium and the second is called as denser medium. Okay. So what do you mean by rarer and denser medium?
Rarer means it will absorb light more and denser will absorb light less.
Not exactly. Not exactly. So when the ray is traveling like this, it is hitting the surface. Okay, at the point of incidence, you will draw a normal. Normal is a common thing. The ray is supposed to travel in this path. But what will happen? The ray will start either bending towards a normal or bending away from the normal, depending on from which medium to which medium the ray is traveling. Okay. Now, if I take 1 and 2, if I do a comparative study of speed of light, if speed of light in medium 1 is greater than speed of light in medium 2, then medium 1 is said to be what?
Rarer.
That is what is said to be a rarer medium. Similarly, medium 2 will be called as denser medium. So you cannot call some medium randomly as rarer and denser. You have to do a comparative study to understand which one is rarer medium and denser medium. So they are comparative variables. Everybody understand what I'm trying to say?
Yes.
Right. So that is one thing. Secondly, there is a parameter called as refractive index that we need to understand. So refractive index of a medium is something like this. It is the ratio of
Speed of light in
it is the ratio of speed of light in what? Dash.
vacuum.
Correct. Speed of light in a
Given medium.
yes. You're right. And refractive index is represented by the symbol mu. So mu is equal to C by V. See, most of them get confused, okay? They think that is the speed of the light in medium to the speed of light in vacuum. But you can remember it like this. Refractive index is a parameter which is always greater than 1. So speed of light in vacuum is the maximum. That is 3 into 10 power 8 meters per second. Okay. So speed of light in vacuum should be in the numerator and speed of the light in the medium should be in the denominator. Am I clear? And it is a dimensionless quantity. Now, whatever I spoke here is called as absolute refractive index. What is it called as? Absolute refractive index. Why we call it as absolute? Because you're doing a comparative study with respect to a parameter which is already known. Speed of light is fixed, but the speed of light in a medium is variable. Okay, so then you can ask me, what is the opposite of absolute? It is called as a relative refractive index. Relative refractive index. So it is something like this. Mu2 1 can be written as mu2 divided by mu1. So mu2 is refractive index of the second medium with respect to 1 is equal to refractive index of the second medium to the refractive index of the first medium. Then mu2 can be written as C divided by V2 divided by mu1 can be written as C divided by V1. C and C will get cancelled. V1 divided by V2. So mu2 by mu1 is equal to V1 by V2. If you observe one important thing, we can understand that the refractive index is inversely proportional to the speed of the light. So from this, what is that we can understand is, we know that the speed of the light in the rarer medium is greater than the speed of the light in the denser medium, accepted. VR is greater than VD, which implies μr is less than μd. That is why if they give you two refractive indices, how will you understand which one is rarer and which one is denser? The one which is having the lesser value of refractive index is the rarer medium, and the one with the greater refractive index is the denser medium. Clear? Please make a note of this point. Okay. The last topic of discussion for today is laws of refraction. So what are the laws of refraction? If I take this as the angle of incidence, okay, it has nothing to do with angle of incidence, the first phase. What are the first laws there?
The incident ray, the refracted ray, and the normal all lie in the same plane.
Incident ray, refracted ray, and normal all lie in the same plane. Second, ratio of
Angle of incidence to the angle of reflection.
yes, refraction. Sine of angle of
The same.
the sine of angle of refraction is what?
Constant.
Is equal to refractive index. Is equal to constant, and that constant is actually called as the refractive index. Right? So sin I divided by sin R will be equal to mu2 1 or mu2 divided by mu1. Where this is medium 1, this is medium 2, where this is R. It can bend towards or away from the normal. But that depends purely on the way the light is traveling. That is whether it is traveling from rarer to denser or denser to rarer. Okay. Let me explain one small point. When light travels from rarer to denser medium, what happens?
I think it will move towards the normal, right?
Think about it. Towards or away? Towards is right. So light bends towards the normal. You guessed it or you know this?
So I studied it in 10th, but I forgot it. So I just tried it.
Suppose if you forget, how will you recollect? What is the logic behind it? Why should it bend? Did someone say that this should happen? If I take this as the angle of incidence, if this is rarer medium, this is a denser medium. Okay. Then I will call this as mu1, this as mu2. What is the relation? Can I say mu2 is greater than mu1 accepted? Correct? So if the actual path is this thing, try to understand the logic. If this is the actual path, then this should also be angle of incidence because they're vertically opposite angles. Correct? Now, mu1 by mu2, I'm calling it as, sorry. What does sin I by sin R tell us? It is equal to mu2 by mu1. See, sin I by sin R will generally be the ratio of the refractive indices taken in the opposite direction. mu2 by mu1. But mu2 is greater than mu1. So mu2 by mu1 will be greater than 1. Correct? So sin I will be greater than sin R. Now tell me one thing, is sin an increasing function or a decreasing function? between 0 to 90 degrees is sine
Increasing.
and it is increasing, right? That implies I is greater than R. When I is greater than R, the ray has no other option other than bending towards the normal so that this becomes R. It is then this value can be greater than this value. Accept it. Now you understand why it is bending towards the normal. It is
Yes.
purely because of Snell's law. You need not memorize it. If at all you forget in the exam also, you can just derive it in 2 steps. Okay, if you have a confusion. Similarly, if you do the vice versa, that is when the ray is traveling from denser to rarer medium, it will start bending away from the normal. When I say bending away from the normal, it is away from the normal as well as the actual path. So yeah. So it will be something like this. When the ray is traveling from denser to rarer, this is the actual path. This is something like this. So the angle of refraction in that case will be greater than the angle of incidence. This is the ray travels from denser to rarer. These are all the outline. These are all very basic stuff. Okay, based on this, we will see certain important phenomena in tomorrow's class, like total internal reflection, the applications of total internal reflection, prism, all these things we will discuss. Clear? Any
Yes.
other doubts for today's class?
No, sir.
Oh. Then we'll wind up. Yeah. I'll see you all tomorrow.
Thank you, sir.
Thank you, sir. Thank you, sir.